Welcome dear student and Jai Swaminarayan. In the previous video, we were discussed about the Bohr's model of an atom. And from the Bohr's atomic model, we will understand the distribution of the electron in the different cell, distribution of the electron in the different orbit for the different element for the first 18 elements, right? For the first 18 element we will discuss the electron distribution in the different orbit like a k orbit, l orbit, m orbit, n orbit, or we can say that the first orbit, second orbit, third orbit, fourth orbit, and from that we draw the atomic structure of the first 18 element, right? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. That how, what is the atomic structure of this all the element we will discuss in the previous video. But how many number of the electrons in the atom of an different element? It can be represented by the atomic number and the mass number, right? So dear student, in this video we will discuss about the atomic number. From the atomic number we can know that how many numbers of the electrons are present in the atom, and the mass number, how many number of the protons and the neutrons are present in the atom, right? So we will discuss in this video atomic number and the atomic mass. Also we will discuss the isotopes and the isobar of the different atoms. So dear student, let us start with the atomic number. What do you mean by the atomic number? First of all, the atomic number is represented by capital Z, right? The atomic number of an element is the number of protons present in the nucleus of an atom of the element. So atomic number is the number of proton present in the nucleus of an atom. So here we can say that the atomic number Z represents the number of proton present in the nucleus of the atom, right? All the atoms of an element have a same atomic number. So if we consider the one element and we consider the atoms of the same element, right, have a same atomic number. So we know that we will discuss about this like a different atomic number, different element. So the atomic number of an element is the number of protons present in the nucleus of the atom, and all the atoms of the element have a same atomic number, right? For example, if we consider in the first 18 element, how the atomic number is present represented by a first 18 element. First element is a hydrogen. The atomic number of the hydrogen is a 1. That means it has a 1 proton in the nucleus of the hydrogen atom. Second element is a helium. The atomic number of the helium is a 2. That means the helium atom, in the nucleus of the helium atom there are 2 protons, right? Atomic number of the lithium is a 3, right? So it means it has a 3 proton in the atoms of the lithium, right? Similarly, you can understand the atomic number of all the first 18 element. Let us see that first 18 element we will discuss that here, right? Hydrogen, atomic number of the hydrogen is 1, helium, atomic number of the helium is 2, lithium, atomic number of the lithium is 3, beryllium, atomic number of the beryllium is 4. That means in the nucleus of the beryllium atom there are 4 protons are there. Boron, 5 protons, atomic number 5, carbon, atomic number 6, nitrogen, atomic number 7, oxygen, atomic number 8, atomic number of fluorine is a 9, atomic number of neon is a 10, atomic number of the sodium is 11, atomic number of the magnesium 12, atomic number of aluminium 13, atomic number of silicon 14, atomic number of phosphorus 15, atomic number of sulfur 16, atomic number of chlorine 17, and atomic number of argon 18, right? So this atomic number of the different element represent the number of protons in the nucleus. Now dear student, we know that the atom is electrically neutral, right? So the number of proton present in the nucleus is equal to the number of electron in the orbit, right? So this atomic number represent the number of proton, and same amount of the electron are present in the atom, right? So here the atoms is electrically neutral, so the number of protons and the number of electrons are same, and the number of protons and the number of electrons can be represented by the atomic number, right? So hydrogen, helium, lithium, beryllium, boron, carbon, neutron, nitrogen, oxygen, all the atomic number is given in the previous video, right? So you have to remember the atomic number of all the first 18 elements, and the atomic number of the element is the number of protons or the number of electrons present in the atom, right? So understand dear student, what is the atomic number? The atomic number of an element is the number of protons present in the nucleus of an atom of the element, right? You know atomic number of all the first 18 elements, and from this atomic number we can represent the number of protons, we can calculate the number of protons in the nucleus and the number of electrons in the orbit. Now second number is the mass number, right? The mass number of an element is the sum of the number of protons and neutrons, that is combinedly called the nucleons, present in the nucleus of an atom. So here in the nucleus of the atom, the proton and neutrons are there, right? And the protons and neutrons lies in the nucleus, so the protons and neutrons combinedly together known as the nucleus. So mass number is the total mass of the atom is concentrated on the at the nucleus of the atom, and the mass number represents the sum of the number of protons and the neutrons in the nucleus, right? So from the atomic number Z we get the number of protons, and from the mass number we get the number of protons and the number of neutrons. So from the mass number and the atomic number we can easily calculate the number of protons, number of electrons and the number of neutrons in the atom, right? So here the mass number is equal to the number of protons plus number of neutrons, right? Mass number is represented by capital A. The mass of an atom is mainly the mass of the protons and the mass of the neutrons in the nucleus of an atom, right? Of an atom. So here the mass number represents the number of protons and the number of neutrons in the nucleus. For example, if we considering the carbon, the mass number of the carbon is a 12. So number of protons plus number of neutrons in the carbon atom is a 12. But the atomic number of the carbon is 6. So we get from the atomic number we get that in the carbon atom 6 protons are there, right? So out of this 12, 6 protons and the 6 neutrons are there. So the total mass of the carbon atom is a 12U, 12 AMU. AMU is the unit of the mass, atomic mass unit, right? So the atomic mass number of the carbon is 12. That means it in the nucleus of the carbon atom there are 12 proton and neutrons are there, but the atomic number of the carbon is 6, right? So it has a 6 proton and the 6 neutron. Aluminium, the mass number of the aluminium is 27, and from the above table if you get the atomic number of the aluminium is a 13. So out from 27, 13 protons are there and 14 neutrons are there in the aluminium atom. So total mass of the aluminium atom is a 27 AMU. Similarly, sulfur. The mass number of the sulfur is 32 and the atomic number of the sulfur is a 16. So atomic number of the sulfur is 16. That means it has a 16 proton, right? And atomic mass is a 32. That means the proton plus neutron is equal to 16. So we can say that the sulfur in the nucleus of the sulfur atom, 16 proton and the 16 neutrons are there. So the mass of the sulfur atom is a 32 AMU, right? Understand what do you mean by the mass number? The mass number of an element is the total number of protons and neutrons present in the nucleus, right? We can write like this: capital A is equal to Z plus N. So if you want to calculate the number of neutrons present in the nucleus, number of neutrons n is equal to capital A minus Z. Here n is the number of neutrons, A is the mass number and Z is the atomic number, that is the number of protons. So if the number of atomic mass, number of proton is subtracted from the mass number, we get the number of neutron. So dear student, understand atomic number and the atomic mass number, right? So from the atomic number we get the number of protons and the number of electrons, and from the mass number we get the total mass of the nucleus and the number of neutron present in the nucleus, right? Understand? So now dear student, understand from the atomic number and atomic mass we know the number of protons, number of electrons and the number of neutrons. How we can represent the atomic number and the mass number as a symbol, right? So in the notation for an atom, the atomic number, mass number and the symbol of the element are written to be as like this. So here we write the symbol of the element, that means H for hydrogen, N for nitrogen, O for oxygen. Mass number is represented on the left hand side top corner of the symbol of the element. So here the mass number is represented, and at the bottom of the left hand side bottom corner we write the atomic number. For example, the nitrogen has the atomic number 7 and the atomic mass 14. So nitrogen element is written as capital N 714, right? So at the top we write the mass number and at the bottom we write the atomic number, right? So this atomic number 7 represent the number of protons. So in the nitrogen atom 7 proton and the 7 electrons are there, and mass number minus atomic number 14 minus 7, that means 14 minus 7, that is equal to 7 number of neutrons are present in the atom of the nitrogen, right? So understand how the atomic mass and the atomic number is represented in the symbol of the element is represented by a atomic mass and the atomic number, right? So now dear student, we understand about the isotopes. First of all, what do you mean by the isotopes? The isotopes are the atoms of the same element having the same atomic numbers but the different mass number. The atoms of the same element having the same atomic number but the different mass are called the isotopes of the element, right? So isotopes are the atoms of the same element having the same atomic number but the different mass number. The atomic number of the atoms are same but the mass number of the atoms are different. For example, the hydrogen has a 3 isotopes. They are protium, deuterium and tritium. Protium, it is called the hydrogen only also, right? So the hydrogen has a 3 isotopes, right? Protium, that is the hydrogen itself, deuterium and the tritium, right? So atoms of the protium, deuterium and the tritium is shown in this figure. So in the protium, deuterium and tritium, the atomic numbers are same. The atomic numbers of the H11, that is the protium, atomic number of the protium is a 1, atomic number of the deuterium is a 1, and the atomic number is a tritium is also 1. So atoms of the same element, these are the atoms of the hydrogen element, and which has the same atomic number as a 1, right? But the atomic mass number of all the three isotopes are different. So if the atomic mass number is a different, they are called the isotopes of each other. So understand, hydrogen has a three isotopes: protium, deuterium and tritium. Protium has a one proton only, and one, there is no neutron in the protium. So hydrogen has a one proton, there is no neutron in the hydrogen. Deuterium has a mass number 2. That means deuterium, in the deuterium nucleus, one proton and one neutron are there. And the tritium, the mass number of the tritium is a 3. That means in the tritium nucleus, one proton and two neutrons are there. Similarly, carbon has a two isotopes, C612 and C614, right? So in the C612, 6 proton and 6 neutrons are there, but in the C614, 6 neutrons, 6 protons and the 8 neutrons are there, right? Similarly, chlorine has a two isotopes, Cl1735, Cl1737. So in the Cl1735, the 17 protons are there, and 35 minus 17, 18 neutrons are there, right? So 35 minus 17, 18 neutrons are there. Similarly, Cl1737, 17 protons are there, and 37 minus 70, that is the 20 neutrons are there. So the atoms of the same element having the same atomic number but the different mass number are called the isotopes of the atoms, right? Understand how you can calculate the isotopes of the atom? So now, dear student, we understand about the isobars. Isobars are the atom of the different element having the different atomic number but the same mass number. So isobars are the atoms of the different element, not the same element. Isotopes are the atoms of the same element, but here the isobars are the atoms of the different element having a different atomic number. The atomic number are different, but the mass number are same, right? So here the isobar are the atoms of the different elements having a different atomic number but the same mass number. These pairs of the element have the same number of nucleons. So the number of pairs of the element, pairs of the isobars are the same number of nucleons. That means the proton and neutron, sum of the proton and neutron are same. For example, calcium, the atomic number of the calcium is a 20, and argon, atomic number of the argon is a 18. So both the calcium and argon, the atomic number of the calcium is a 20 and atomic number of the argon is a 18. So both the elements have a different atomic number, right? But the atomic mass of both the elements are same, right? So mass number of both the elements are same, right? So these are the isobars of the, these are called the isobars, right? Similarly, iron Fe and nickel, right? The atomic number of the Fe is 26 and the atomic number of the nickel is 27. So here the atomic number is different but the atomic mass are same. So these two elements are called the isobar, right? So understand, dear student, what do you mean by the isotopes and the isobar? Isotopes are the atoms of the same element having a different mass number, and isobar are the atoms of the different element having the same mass number, right? So dear student, here our chapter of 4 is completed. I hope that you understand all the things explained in the different video number 1 to video number 4 of the chapter number 4, right? I hope that what are the different atomic models explained by the different scientists, right? How the electron arrangement of the atoms, how the electrons are distributed in the different cells of the atoms, right? Then we will discuss about the Bohr's atomic model, distribution of the electron in the different cells, right? Atomic number, atomic mass. From the atomic number and atomic mass, how we can calculate the number of protons, number of electrons, and the number of neutrons. And then after we will discuss about the isotopes and the isobars, right? Isobars and the isobars. So I hope that you understand all the content of the chapter number 4. So in the next video, we will discuss about the answer of the question given in the textbook as well as the exercise. So dear student, keep watching my video.